name is Kelsey. I'm an OpenSciEd teacher and facilitator. This video will go over lesson 14 in unit 6.2. This is the last lesson in the second lesson set of this unit and includes an assessment opportunity to check in on your students' progress. So let's take a look. First, how we got here. In lesson 13, we figured out a bunch of things about particles of solids. We figured out that particles in a solid vibrate back and forth in place. Collisions between particles in a solid, liquid, or gas can transfer kinetic energy from one particle to another. The more particles in a sample of matter that are in contact with another sample of matter, the greater the amount of particle kinetic energy is transferred from the warmer piece of matter to the cooler pieces of matter over time. And the more particles an object is made of, the more energy must leave or enter the system in order to change the temperature of that object. So in this lesson, we're wondering, does our evidence support that cold is leaving the system or that heat is entering the system? Here's the lesson at a glance. So this is an investigation lesson as well as a putting the pieces together lesson. It's 3 days long. We have 30 minutes of material prep, no hands-on investigations, no devices required, and no related videos. This is the lesson at a glance, and here we're looking at day 1. So in this sense-making loop, we start by going back to the claims chart. We have new evidence that we can use to support either if heat is entering the system or if cold is leaving the system when a cold drink warms up. So we sort that new evidence. And then we might gather even more evidence in the butter demonstration if we feel like we don't have enough evidence to support either of the claims yet. From this, we figure out that most of our evidence supports the claim that heat is entering the cup system, causing it to warm up. And heat is energy moving from the hotter thing to the colder thing. So in day 2 and day 3, we continue thinking about which way energy is transferring when we have a system or systems with temperature changes. First, individually, and then in a science circle, we model the cup system to show how energy transfers between particles cause the drink to warm up. On the final day of this lesson, we go back to our driving questions board and practice explaining some related phenomena using what we have learned. Finally, we show what we have learned on an individual assessment for another similar phenomenon. From all of this, we figure out that when things warm up, they gain energy through particle collisions that transfer energy from the particles with more energy to the particles with less energy. And when things cool down, they lose energy through particle collisions that transfer energy from the particles with more energy to the particles with less energy. So we figure out in this lesson that temperatures change when energy moves from warmer to cooler matter, and when energy is transferred when higher energy particles come into contact with lower energy particles. From all of this, we're left wondering, how do certain design features slow down the transfer of energy into a cup? I will highlight 3 key moments in this lesson. In part 2, we have our evidence sorting activity. We come back to the claims chart we started looking at lesson 11. Students first sort this evidence with their groups, and then in a science circle, we sort it as a class. This drives a discussion about what the evidence supports, either heat entering or cold leaving. The evidence gathered in lessons 11 through 13 should better support heat entering the system, while the evidence gathered before lesson 11 might be more neutral, and students could say that it supports both. So this is really good practice for students to use evidence to support their thinking, and you as the teacher can see from this discussion if students need more evidence. If students are still debating about cold leaving the system, you can then do the butter demonstration, where you gather more data then and there in the circle to support the claim that heat enters the system. In part 8 of this lesson, we meet again in a science circle, and the goal is to use everything we know from the first 2 lesson sets to develop a model that explains the original phenomenon. Before the circle, students have time to generate ideas individually using this worksheet you can see on the screen, and I would give them time to discuss it in pairs or groups before or during the circle as well. Then, as a class, we create this model. So in this model, we draw particles, we show particle motion and different amounts of kinetic energy and energy transfers. We might use words to describe what's happening, And I ask students to discuss what evidence we have to support it and add just one piece of evidence to the model as more practice. All of this is crucial practice as students will be asked to do this for a similar but new phenomena on an assessment in the next day. So here's that assessment. This is part 10, the icing injuries assessment. This is a formative assessment at the end of this lesson set. I really like this phenomenon because it is something almost every kid in the room has experience with, putting ice on a body part when it's injured. And I can ask them to share out their experiences. How does the ankle or the body part feel? How does the skin feel? What happens to the ice in the bag over time? And they can share all these things out. So in this assessment, students are given some data around this phenomenon. You can see the data on the screen. And then they are asked to argue between two claims. One claim is that cold is leaving the ice pack and going into the skin. And the other is that heat is leaving the body and going to the ice pack. Then students draw particle models to show these energy transfers causing the temperature changes over time that they see in the data. I have a tip about this assessment that I will go over in the next section of this video, but this is a really great point to assess students' progress with the concepts we have figured out so far in this unit and to give students feedback on their modeling skills. Material management tips and tricks. I have 2 tips and tricks for this lesson. So in part 3, we have the butter demonstration. This butter demonstration comes in the science circle on day 1. It's optional, but if students are still not convinced that heat is the thing that's entering the system rather than cold leaving, then this can be done in the circle. And then when you have this data, you can go back to the claims chart. So it's helpful when we're doing this and students are trying to figure out if heat is entering or if cold is leaving. It's helpful to keep students focused on what we know about things that are warmer. They have more kinetic energy. This helps them think about gaining and losing energy. So if we know that things that are warmer have more kinetic energy, where is the energy coming from? If something is getting colder, where is the energy going? At this point, you can develop a definition of heat. So this is explained in the teacher edition, but it is easily missed. To co-develop this definition of heat, I might say something like, when I hear you all using that word heat, I hear you using it like it's doing something, like it's moving. So first, when we talk about heat, what are we actually talking about? And so students will get to explaining, well, heat is, particles are moving faster, they're getting faster. So then we start developing this definition. Okay, so heat is kinetic energy. And we're describing it like when we talk about heat, we're talking about it moving. So then I might add on to this and maybe give them a sentence starter. So heat is kinetic energy moving from blank to blank. So if heat is energy moving, then that means that it's going from one place to another. Where is it coming from and where does it move to? And with this sentence starter and this discussion that we're having, and given what we're seeing in the butter demonstration, the students would say that it moves from the hotter thing to the colder thing. So this is one more definition that we now have to explain temperature changes. The butter demonstration feels like a natural place to develop this definition. I've tried defining heat at different places in this lesson when I haven't done the butter demonstration, and it hasn't worked as well. So the butter demonstration is optional and not necessary if your students are already convinced that heat is the thing that's moving. But it might be worth it just to develop this definition of heat, because I have found that it is very helpful for students when they're trying to explain temperature changes. Okay, my last tip for this assessment is in part 10 in the icing injuries assessment. So this is a pretty big task because students are asked to draw particle models showing energy differences and energy transfers that cause temperature changes. So I always take the time to develop a gotta have it checklist with my students before they do this assessment. It helps a lot to have just made the consensus model for the cup wall together and to have that visible as an example of a good model that has evidence to support it. So you can have that up and you can talk about, well, what did we use in this model what might we need when we're trying to explain this similar phenomenon. So the gotta have it for this assessment, it should include particles of solids, liquids, and gases, particle motion, kinetic energy transferring, and evidence. Co-developing the gotta have it checklist with your students, it helps them build their modeling skills, and then they go into this task with an idea of how to actually complete it. And then the students have the checklist to guide them, and you can use it to give them feedback. So when you're giving them feedback on their models, you can come back to the gotta have a checklist and say, look, this is what we determined we needed to show. Do you have all those things? Or you have this, but you don't have that. And then you can also match that up with the data. So we have these things on our model. Does that explain what we're seeing in the data? So all of these things help your students find more success with this assessment, and then also help you give them feedback on how they can improve. Okay, for our word wall management, we add the word heat to the word wall in this lesson. Materials used from the previous lesson. For poster management, we will use the claims chart that we originally used, I believe, in lesson 11. And then we create this consensus model poster in this lesson. And I keep this particle model displayed throughout the assessment that they do. And I keep it up for the remainder of the unit. And I even keep it up beyond the unit. These concepts are built on in unit 6.3 and beyond. So I leave it on the wall pretty much for the rest of the year. And that's it. That's the end of lesson set 2. After this lesson, this unit moves into the final lesson set, which includes an engineering challenge. And in lesson 15, we're wondering, how do certain design features slow down the transfer of energy into a cup? See you all later.